Okay, 1 to 2, what is it? Alright, so you guys need to pause for a minute because we didn't look at this yet. Pause for 90 seconds, label each of those sides. Alright, pause. Alright, we're back. What is it? I would probably go isothermal because it is pretty darn shallow, but it could be adiabatic. I don't really know. They look very similar. Maybe isothermal. This one's indefinite. What's that? Isochoric for sure. How about 3 to 4? That looks fairly steep, so I would say adiabatic as well, although I wouldn't be able to prove it to you. And then 4 to 1, isochoric. Yes. Okay? And then we start in the same state that we started in, but we probably, well, no probability of that. Is any work done at any time during this cycle? Yes. How many of the 4 steps have non-zero work? Only 2 of them. Okay? The 2 isochoric steps, there's no work done at all. No, not positive work, not negative work, it's just 0. This one was positive work or negative work? That one is negative work, and how would we find it? Area. Okay? We would find the area under that curve. I'll just do that in red. Alright. How about this one? Positive work or negative work? Positive work, how would we find it? Area underneath. So how would we find the work done for the entire cycle? You could subtract the red from the blue, that would work. Or you could find the area inside the cycle. That would work too. Okay? So for a thermodynamic cycle, you can find the area like inside all those lines, all those segments, and that absolutely will give you the net work done during the cycle. It's positive work sometimes, negative work other times. Find the work inside is the quickest way to do it. Alright, let's look at one other cycle and go ahead and identify those 4 chunks by name. Alright, so A to B, B to C, C to D, D to A. Go ahead. Yeah, we already got 4, so this is easy. Alright, what's A to B? Isothermal or adiabatic. It looks pretty steep to me. I'd probably say adiabatics for this one, but you can say isothermal, fine. B to C. Isobaric, right? Constant pressure. Alright, and then C to D. Yeah, probably adiabatic, maybe isothermal. Hard to say. And then D to A. Isochoric. And again, this is a cycle because our gas ends up in the same state that it started in. So like when we have an engine with like the piston repeating itself, you know, however many times a minute, that would look something like one of these. Now, we see some other stuff. In fact, this says a diesel heat cycle, so this would be like for a diesel engine. I see some S's there. So right here in the blue it says delta S equals 0, and that's compression. Here it says delta S equals 0, and that's an expansion. Have we ever seen S before? No, well, true, but this is a capital S. The displacement's a lowercase s. We haven't seen it before. Anybody peek at topic 10.3 yet? So topic 10.3 is only 4 objectives. They all deal with a concept called entropy. Is that something you met in 9th grade or no? No? You didn't read it? Alright, so entropy is a quantitative thing. We are only going to deal with it qualitatively next class. But what I'll say right now is that delta S equals 0 means that there's no temperature change. So the delta S equals 0 actually is telling us that those are isothermal, they're not adiabatic. You do not, that's beyond the scope of this topic. You do not need to know it. Okay? We do need to know some things about entropy, which we'll do next class, but we don't need to deal with it quantitatively in this course at all. What about enthalpy? Did you hear about that one in 9th grade?
I've heard, although...
Yeah. So the entropy and enthalpy, I mean, that's all stuff that you typically do in chemistry, but sometimes you do in physics too. And again, before I close this, we could find the net work done in the cycle by finding that area inside the cycle on our pressure volume. Lay a question? No? All right. So what I'd like to do now is have you guys working with some examples of what we did today, what we did last class. I actually do kind of want you to do the packet questions like without help. So we're going to work on a few examples from the textbook. If you do not finish this, you are not going to have to do it for homework. So grab however many books your foursome would like. And these are the ones that I'd like us to put attention to. I don't expect that you're going to finish all, what is that, 7 of these in the next 20 minutes, but you can probably get most of them done. Let me know if you start struggling and need a pointer with things.
Elizabeth, I think they just got a close-up of you.